Hello coders, welcome to my channel. I am Aniket and today we will be discussing the problem count sorted digit groupings from GFG. Let's read the problem first. Given a string S consisting of digits, you can split it into contiguous substring groups. For example, the string 112 can be split as these many ways. So a grouping is considered valid if the sum of digits of the subgroups form a non-decreasing sequence from left to right. Means if you partition your string in some of the substrings like A, B and C, so the sum of A should be lesser than equal to sum of B and sum of B should be lesser than equal to sum of C. Let's see this with an example. Let's see, we have a string 1112 and if you do partition it here, then the sum of in this case we consider only two partitions, two subgroups. So in this case, if you find the first subgroup sum, it is 1, and find the second subgroup sum, it is 4. Is this condition hold? Yes, this condition is hold, so it is valid partition. This type of partition is valid. If you consider the partition here, then what is the sum of first subgroup? It is 2, and sum of second subgroup, it is 3. So is this condition hold? Yes, in this case also the condition is hold, so this type of partition is also valid. If you consider the partition like here, then the sum of first subgroup is 3 and the sum of second subgroup is 2. Is this condition hold? No, this condition is not hold. So in this case the partition is not valid. I hope you understand which type of partition is valid and which type of partition is not valid. Finally, you determine the total number of such valid groupings for the given string. You find the total number of that number of groupings that you can do such that those groupings are valid one. So what is the key observation for this problem? Let's see it. The key observation for this problem is for every position we have for every position we have several choices. What are those choices? Let's see it. First choice is, should we cut after one digit? Should we cut after two digit? So this and so on. In this way we can easily partition our string into various possible partitions. So the key observation is, for every position we have several choices. Should we cut after one digit, or should we cut after two digit, or should we cut after three digit, and so on. Let's make a tree diagram to visualize it better. Let's see the our tree diagram. So let's see, we consider this string itself 111 and 2. For this string there are four choices. First choice is cut after one digit, so the string will result into this type. If you cut after two digit, so the string will result into this type. If you cut after three digit, so the string will look like this type. And if you cut after four digit, so the string will be equivalent to itself. So afterwards, if you consider this branch, then you can cut it also. In this case, if you can cut it in three ways. If you cut after one digit, so the string will look like this, and if you cut it after two digit, so the string will look like this, and if you cut after three digit, so the string will look like itself. In this case also there are two choices. You can split it after one digit cut or after two digit cut. If you split it after one digit cut, so the string will look like this, and if you cut it after two digit cut, so the string will look like this itself. In this case if you cut it after one digit, because here the only possibility of cutting is only one digit after, so if you cut it after one digit, so the string will look like itself. In this case the string is already cut, there is no possibility of further cutting, so further partition, so in this case there is no branching deeper. If you consider this case, there is a further scope of partition. If you cut after one digit, the string will look like this, and if you cut after two digit, the string will look like itself. In this case there is no scope of partitioning. In this case there is a scope of partitioning. No, in this case also there is no scope of partitioning. So here these uh, end branches are the valid partition, are the number of partitions for the this string. I hope you got this, how you can find all possible partitions of a string. Out of all these partitions, let's see which partitions are not valid. This partition is valid, this partition is valid, this partition is also valid, this partition is also valid, this partition is not valid because here the sum of first subgroup is 2 and the sum of second subgroup is only 1. So it is not holding the non-decreasing order. This partition is valid, this partition is not valid because here the sum of first subgroup is 3 and the second subgroup is 2. So in this case it is not holding the valid condition. This partition is also valid. So out of 8, 6 are valid and 2 are invalid partitions. So I hope you got the question. While constructing the tree, you have observed that there are two information that you have to remember. What are those information? The first information is where you are currently at. Where you are currently means the ID of the string. And the next observation, what was the previous sum? The next observation is what was the previous sum. Let's see these two parameters and construct the same tree with these two parameters. The first parameter, first we start with 0 index and 0 previous sum. First parameter indicate the ID and the second parameter indicate the previous sum. I hope you got this. Let's make the tree. First there are 4 possible cutting. If you cut after 1, then you reach at 1 index and the sum will be equal to 1. For this string, I consider this tree. If you cut after 2 digit, then you reach at 2 index and the sum will be 2. If you cut after 3 digit, you reach at third index and the sum will be equal to 3. If you cut after 4 digit, you reach at fourth index and the sum will be equal to 5. So as you can see here, there is no scope of further partitioning, so you should return 1 because here the previous sum is 0 and the current sum is 5, and current sum is greater than the previous sum, so you should return 1. So what is the valid partition till now? Till now you found only one valid partition, that is at the node of 4 comma 5. If you consider a further partitioning for this node, there are only three partitions. If you cut after one digit, you reach at 2 index and the sum will be 1, current sum. If you reach at the If you cut after a 2 digit, then you reach at third index and the sum will be 2. If you cut after 4 digit, you reach at fourth index. If you cut after 3 digit, you reach at fourth index and the sum will be equal to, just like I discussed in the above node also, the sum will be equal to 4. So as you can see here also, you reach at the end of the partition, end of the string, and there is no scope of further partitioning. And as you can see also that the previous sum is 1 and the current sum is 4, and previous sum is lesser than equal to current sum, so you should increment your valid partition by 1 also. There, in this case also, there are further two possible partitioning. If you cut after 1 digit, you reach at third index and the sum of digit will be, if you reach at the third index, the sum of current sum will be equal to 1. If you cut after 2 digit, then you reach at fourth index and the sum will be equal to, just like above, 3. So as you can see here also, you reach at fourth index and the previous sum is lesser than equal to current sum, so you should increment your valid partition by 1. And in this case also, there are further partitioning. If you cut after 1 digit, you reach at fourth index and the sum will be equal to 2. So the sum will be equal to 2. If you carefully see, here you reach at fourth index, but the previous sum is 3 and the current sum is 2. Previous sum is greater than the current sum, so you need not increment the valid partition by 1. You should return only by itself, not increment any digit. So the key observation is, if you reach at the last index, that is n, return 1, because if you return 1, this indicates that the valid partition is found. But in this case, you reach at last index, but if you carefully see, you didn't reach to the fourth, because when you reach at fourth and compare the uh, sum, previous sum and current sum, you will not branch it. This branching will not happen anyway. So the main base case is, when you reach at the id is equal to n, you should return 1, not -1, you should return 1. I hope you got this. There are further partitioning in this case also. If you partition after 1 digit cut, then you reach at third index, and if you reach at third index, then the further partition, the sum will be 1, and you if you cut after 2 digit, then you reach at fourth index and the sum will be 3. Sum will be 3 in both of these cases. In this case, the previous sum is 1 and the current sum is 3, so you should increment your valid partition by 1. In this case also, there are further partitioning. If you cut after 1 digit, you reach at fourth index and the sum will be 2. Here in this case also, you reach at fourth index and the current sum is greater than the previous sum, so you should increment your partition by 1. So in this case, there are further partition. Only one partition is possible. If you cut after 1 digit, so you reach at fourth index and the sum of that fourth index will be 2. So in this case also, the previous sum is lesser than equal to current sum, so you should increment your valid partition counter by 1. In this case, if you carefully see that the previous sum is 2 and the current sum is 1, so previous sum is greater than the current sum, so it is not possible that you go into this branch. You cannot go into this branch, so this is not further expanded. And if you carefully see that all of the branches are terminated, and you will find your valid partition answer in your valid partition variable. So 1 plus 1 plus 1 plus 1 plus 1, that is 6. So 6 is your answer. I hope you got this. How can you construct the tree using these two parameters, id and prev sum, and finding whether you should partition it there or not. If the current sum is lesser than if the current sum is lesser than the previous sum, then you should not partition there. If the current sum is greater than the or equal to previous sum, then you can partition it there. And if by anyhow you reach at the fourth index, then you simply increment your valid partition counter by 1. I hope you got this. Now let's discuss our code. In this code we use dp array because in this problem there might be possible that the overlapping subproblems can be occur. So we use dp array with memoization so that we don't calculate same thing again and again. I hope you got this. Similarly, if the I initialize my string s and n globally so that in my memo function I do not worried about those. I only consider the changing parameters, that is id and prev sum. I initialize my dp array as n plus 1 row and 1000 as a prev sum because according to problem constraint the digits can go up to 0 till 9, and the length of those digit is only 100. So 100 into 9 in worst cases will give you 900 as sum. So the previous sum can goes from 0 to 900, not greater than 900. So in this case I took 1000 for to be a safer side. So in this case we consider memo of id prev sum. If the id is equal to the n, then I simply return 1. If I previously calculated this id comma prev sum, so I use it, don't calculate it again and again. This saves my time. So firstly I initialize my sum variable as 0 and initialize my answer variable as 0, and the 0 comma 0 will store the number of all valid partitions which can be occurred if you start at 0th index and prev sum is 0. So you should return finally your answer, and if the sum is greater than or equal to prev sum, then you go into deeper branch. Otherwise you don't go to deeper branch. This will ensure that whenever you reach at id is equal to n, then will guarantee you the partition is always valid. I hope you got this. Please like and subscribe my channel. Thank you for watching my video. If you are stuck in this code, then I prefer you to dry run it on this test case 1112. It will clear to you because it is a recursive test case. It is a recursive problem, so recursion requires a dry run approach. So you should dry run it by yourself. I think I will be able to clear your intuitions behind the problem, and my code is clear to you. Thank you for watching my channel. Please like, subscribe my video. Thank you.